All right, so you solved these types of questions in an assignment last night, right? And we'll talk about that assignment here in a little bit. But these problems were probably of the harder variety because we get the relationships of 1/3, 2/3, and 1/2. And I think the biggest issue is people don't necessarily know which side of the equation to put the 2/3 or what side of the equation to put the 1/3. We might know what ratio needs to be involved, and we might know what parts need to be set equal to each other, but we don't know which side to put those fractions on. So I want to kind of walk you through the process of doing this. Okay. Regardless of the type of triangle you have, I'm just going to draw an arbitrary triangle here, and I'm going to deal with maybe that median. Okay. Using other medians, we would be able to find out that maybe our centroid shows up maybe right there. Okay. So we'll call that point C for centroid. I'm going to call this point over here M because it's a midpoint. And I'm going to call this point here V for vertex. Okay. Now, every single time you do one of these problems, this distance here is shorter than that distance. Is that okay? So when we think about 1/3 and 2/3, which one of those is smaller? 1/3, right? So what we find out is that this blue distance is always 1/3 of the median. Okay? And when I say it that way, 1/3 of the median, Algebra 1 said of refers to what operation? Multiplication. Okay? When you see the word of, it means multiply. So 1/3 of the median. Okay? The red segment here, that is always 2/3 of the median. Is that doable? All right, so if you can remember that picture, you should be able to get every one of these problems correct, at least geometrically. You should be able to set them up correct. All right. You have to be able to pay attention to the parts that they give you or the parts that they're talking about in the problem. Okay. Do they talk about the whole median? And do they then talk about the blue part? Are those the parts in the problem? Or are they talking about the whole median and the red part? Because if they're talking about any of those things, we use the 1/3 and the 2/3 respectively. Okay. However, some of these questions ask you to compare the blue part to the red part. Well, if I want to compare the blue part to the red part, how does 1/3 compare to 2/3? Or how does 2/3 compare to 1/3? Okay, they add together to give me the whole median. But if I just look at 2/3, that is how much bigger than 1/3? It's 1/3 more, right? If I add 1/3 to it. So 1/3 plus 1/3 equals 2/3, right? So isn't 2/3 twice as big as 1/3? So if they ask you to compare the red one to the blue one, that's where that ratio of 2:1 or 1/2 came from. Okay? Because the red one is twice as big as the blue one, or the blue one is half the size of the red one. Okay? So even though I only write two fractions of the two ratios, there's actually three if we compare the red one to the blue one. There's that 1/2 or 2. Okay? So do a couple examples here with these ratios. It says find xt. Okay? If kx and kt are those two expressions. Okay? Now that 9/2, I cut and pasted too much. 9/2 is the solution here. Okay? When they give you this information, they're first going to give you that picture on the left, bottom left right there. And if you use that picture, it's fine. It's not a big deal. But I think a lot of people get mixed up with that extra median drawn in there. The only reason they give me that extra median is to tell me that x is a centroid, so we can start using these ratios. So I know x is my centroid. I know that t and k are the components that I'm interested in. Okay? So now, if they give me, in this problem here, they give me KT, right? KT is what object in our picture, either one of these pictures. KT is the, come on guys, definition-wise, K to T is a median, okay? So, when I look at that segment, that red segment is my median, right? K to X, let's make that blue, okay? K to X is that portion there of my median, right? Is that doable for everybody? Try that again. Okay. So we got the red part, which is the entire median, right? And we got the blue part, okay, which is a portion of the median, right? If I have that picture relates directly to the diagram that we have at the top, okay? Would you guys agree that this segment right here relates to this one right here? Is that doable? Okay. So down in my picture, K to X. K to X is, now it's this portion that goes from the vertex to the centroid, so it is 2/3 your median. Well, what is the median in my picture? It's K to T, isn't it? Okay. So if I write Kx equals 2/3 KT, I now have the correct generic formula for relating those two things. Okay? And that's what we talked about yesterday. If we go back to the GeoGebra app that I showed you yesterday, we said that Kx is always going to be in a relationship of 2/3 of KT. Okay? And if I read, let's go back to Algebra 1, week 1 of Algebra 1. Does this say Kx, the length from the vertex to the centroid, is, that's what equal means, right? 2/3 multiply means of, right? So 2/3 of the median, KT. Okay? So vertex to centroid is always 2/3 the entire median. Okay? It's just now you have to plug in, okay, what are our values of the vertex and the centroid? Okay? Or what are our particular letters that we're using for our vertex to centroid? What are the particular letters that we're using for the median here? Okay? Too often I get people to put the 2/3 on the other side, put it with Kx. Okay? Here's another kind of way to verify that we have that 2/3 in the right spot. Okay? We want to make Kx and KT equal, don't we? Okay, at the onset, those two things are not equal. Okay, let's just put a question mark there to remind myself that I don't know them to be equal. Okay, if we look at them down here, obviously, the red distance is longer than the blue one, right? Okay, so what we need to do, if we want to make them equal, we need to multiply one side by some number. Okay, and I'm going to multiply the bigger side. So KT is the bigger side. I want to multiply that by some number so it shrinks it to that size right there. Does that make sense to everyone? Okay. So if I can take that red distance and shrink it so it gives me K to X. Okay. Now, what kind of number do I need to use to multiply by some particular value to shrink that particular value? Say I gave you the number 10. Okay. Let's just say we have 10 over here. It's KT. If I wanted to shrink 10 through multiplication, what type of number do you have to use? I heard somebody say fraction. Okay, that is correct, but kind of incorrect as well. If I use 5 halves and multiply 10 by 5 halves, it gives me 50 over 2, which is 25. So that made 10 go to a number that was bigger, right? But if I multiply 10 by a half, that went to 5 now, right? So where is 1/2 on a number line compared to maybe where 5/2 is on a number line? Between 0 and 1. Okay? So if I want to shrink a number, I need to multiply it by something between 0 and 1. Okay? Well, is 2/3 between 0 and 1? Yeah. So I know that I want to take KT, a larger distance, and multiply it by a number between 0 and 1, and it should shrink KT, and it will shrink it down to the same size that KX is. And it'll give me that equation. Is that doable? Okay. Now, there's a lot of other things that you can do from that stage to get the correct solution here. Kind of show you maybe a couple different processes. We'll plug in 2x plus 5 for kx is equal then to 2/3 of kt, which is then 12x plus 3 all over 2. Okay? And here's the battle that I have every year with this information. And really, in regards to any course that I teach, any concept that I teach, is that we've only had 1 year of algebra. And I fully understand it. I've been doing algebra since I was in 8th grade. So I'm a little bit better at it, right? And I use it on a daily basis. It's my job, so I understand that I'm better at it than maybe you are. Okay? Because you don't use it every day. You don't maybe have the same interest level that I have in it and all that kind of stuff. But there are so many different ways that we can address this question and solve for x. But the more you know algebra, the more those doors open. Okay? And my hopes are that we don't kind of try to pigeonhole ourselves into one process to solve an equation like this. Because sometimes that one process might either run me into a roadblock or it might just be really hard. Okay? A couple different things you could do here. Okay? First thing I recognize is just kind of draw maybe a comparison over here. If I had a number like 2/3 times, let's say, 15/2, what could you do with those 2's? Cancel them out, right? Because what that gives me, ultimately, if I multiply, that'd be 15 times 2 over 3 times 2. And those 2 over 2 is a 1, right? Or it would give me 30 over 6. Well, 30 over 6 is going to reduce down to the same thing that 15 over 3 is. It's going to reduce down to 5, right? Okay. So we can cancel those. So could I cancel that 2 with that 2 right there? Does that make sense to everybody? So I could rewrite this thing as maybe 2x plus 5 equals 1/3. Now that those 2's have canceled, that's where I'm left with that 1 up top. And now there's no denominator left over here, so now it's 12x plus 3. This would be a route that I would use because that 1/3, does 1/3 work well with a integer of 12 from all put together? What's 1/3 of 12? 4, right? Is 4 a nice number to deal with? Yeah. Does 1/3 deal well with 3 for the same reason? 3 times 1/3 is what? 1. So I like using that approach because then when I distribute here, it's really easy to distribute and get back nice values, okay? Integer values, 4x and 1. So now I get 2x plus 5 is equal to that. Can I subtract 2x from both sides? I subtract 1 from both sides, and I get x to be 2, right? Okay. Now, maybe using some other approaches that would be 100% perfectly fine. They just might be a little bit more time consuming. If I do, let's just start, I guess, at this stage here. We have 2x plus 5. Let's say we still canceled everything out. Let's just cancel those 2's out. So now I have 1/3 times 12x plus 3. Okay. Think about this concept. Kind of draw another comparison that we use, kind of similar to this. If I have, let's just say, look at this here. Is x is going to be a what? What's x what's any variable ever represent? Just a number, okay? And we use x because that number, we call it a variable, right? So that variable means it's going to vary. And another word for vary means, or is to change, right? So we use the letter x to show that there's a number that's going to go in there that could be changing, okay? But whatever it changes to, and I multiply it by 12 and I add 3 to it, doesn't that just give me a number? Does that make sense, everybody? So whatever this is, I don't really care what that is, but it's going to be a number. So I have on the right-hand side, I have 1/3 times some number. Okay? Just some, maybe it's a fraction, maybe it's an integer, it doesn't matter. Let's just say it's just some number. Well, let's say that I don't like that 1/3. What can I multiply it by over here to get rid of that 1/3? 3, right? That'll get rid of that 1/3. Or 6 or 12 or whatever. But I can multiply by that denominator of 3 to get rid of the 1/3, right? So now you have 3 times 1/3 times some other number. Let's say that other number, this number right here, which I don't care what it is, let's say it's 10. Okay? Which of the two numbers work really well together here? 3 and 1/3, right? Can I do that multiplication and change that to a 1? And now I have 1 times 10? Okay, so that idea, when I want to come down here and I have 1/3 times 12x plus 3, and I want to get rid of that 1/3. 1/3, 12x plus 3. I'm going to put parentheses here. I'm going to multiply by 3. Okay? And the reason I gave you this information up here, and we tried to draw that comparison, is because of what we need to do down here. This is a number times a number times a number. But when you do multiplication by hand and you're thinking the process through, you only ever multiply two numbers together at a time, right? So 3 times 1/3 are the two that you want to multiply together first, right? Rewrite that then as 1, and then I have my 12x plus 3. Well, 1 times 12x plus 3 is just 12x plus 3, right? So multiply the right-hand side by 3, got to multiply the left-hand side by 3, so we get 6x plus 15. Subtract 6x from both sides, gives me 6x. Subtract 3 from both sides, gives me 12. What's x end up being? 2 again. Same as that, right? My fear, if people are going to use this approach here to get rid of this fraction out front, whether it be a 1/3 or maybe sometimes be a 2/3, is that people want to do this. They want to take that 3 times the third, get 1. But then they want to take the 3 and multiply it by the 12. They want to take the 3 and then multiply it by the 3. They want to distribute this 3 that they brought in to everything. You can't do, you don't do multiplication that way. If I do 2 times 3 times 5, that's 2 times 3, which is 6, right? You're going to take the 6 times 5. You don't take 2 times 3 and get 6. And then take 2 times 5 and get 10. And then take the 6 times 10. You don't do it that way, right? Okay? You do that multiplication, and replace by 6, and then you do 6 times 5. It's the same concept down here. All right? Other approaches. Could I take, let's go back to the original. Can I look at that and realize that this is a fraction times a fraction? Can I take 2x plus 5 is equal to now fraction times a fraction? I take top times top. Well, that algebra means to distribute. So I get 24x plus 6. Okay? And then bottom times bottom. So that gives me 6. Now what can I multiply everything by to get rid of that 6? 6. So I get 12x plus 30 equals 24x plus 6. Subtract 12x from both sides. Subtract 6 from both sides. What's x give you? 2. Same answer, right? Okay. Now that algebra provided larger coefficients, right? Dealing with 24 and 12, and but it's perfectly fine. Even some of you might even want to maybe change the equation up here. Okay. Could I multiply both sides by 3 up here? Multiply both sides by 3, and it gives me 3 kx's. Should equal 2 kt's. Does that make sense? Now think about why that works.
What we're doing there is we're saying 3kx is equals 2kt's. So I can take this kt, and if I put it end to end, I should be able to take 3 of these blue ones and put them end to end, and I should still get the same segment. Does that make sense? So you can do it that way. So I'm going to go (3kx), so 3 times 2x plus 5 is equal to 2 times 12x plus 3 over 2. What's nice maybe in this case of doing that, these 2's cancel. Leaves me 12x plus 3. This gives me 6x plus 15. Subtract 6x from both sides. Subtract 3 from both sides. X again is 2.
All right? So, people come to me all the time and say, I don't understand the algebra. Show me the steps for that. There are no kind of predefined one set of steps that you have to use that you could use. Does that make sense? The way I do it might be completely different from the way you do it. Okay? I might be a person that I change per, because like I said, I deal with this a lot more than you guys do on a regular basis. I change my steps from question to question, depending on what kind of numbers I get. Okay? The next one we do, I'm not going to use any of those approaches. Okay? I'm going to do something a little bit different because the numbers set themselves up for a different process. Does that make sense? The better you understand your algebra, the more efficient you're able to be inside your geometry or inside your science classes or whatever. And that's why we have 2 algebra classes in high school, so we can get better at that, so we can address other areas a little bit more efficiently. Now we have x equals 2. We're not done with the question. They're going to ask us what is the length of x to t, okay? And we don't have an expression for x to t, do we? We don't have that distance, okay? But we do have the ability to kind of maybe find it doing a little bit of segment addition. If I know that x is 2, do we know that this distance here is 9? Plugging in 2 there. So this blue distance is 9. Okay. Now you've got some options here. You can do it maybe two different ways. If I know that this blue is 9, how does that blue relate to that green section? How do we compare those two things together? Going back maybe up to this picture. Okay, I guess it deleted. We had that distance there, which was 1/3, compared to that blue distance there, which was 2/3. How does 1/3 compare to 2/3? It's half, isn't it? Okay, so this distance here is going to be what of this distance here? Half. So half of 9 is that right there. Okay. The other way you could do it is to say I have an expression for kt, which kt is 12x plus 3 over 2. So it gives me 27 over 2. That's the entire red segment. If I remove 9 from that, which is the blue one, so removing 9 is actually removing 18 over 2. Well, 27 minus 18 is 9. So 9 over 2 that way. So neither one of those approaches is going to find you that green distance. But in this problem, there's not an exact value or expression to plug that into. I like those types of questions because they can gauge whether you know 2 concepts. Do you know the centroid concept? And also, do you know the segment addition concept? Okay, so it can test you over 2 things at once. Take a minute and see what you come up with. Just set up an equation. I want you to first set up a generic equation using MF, UF, and what other parts maybe you need. So set that generic equation like we did previously with KT and KX, and then start plugging in your expressions. In about 2-3 minutes, we'll come back and see if we have the correct equation set up first. The setting up of the equations is the geometry, and then we had to rely on our skills of algebra to really answer the question. as you start writing that kind of generic equation, you know that they provide you with UF and MF, right? Those are the things you have to deal with, okay? We look at those things, and UF is from the centroid to a midpoint, okay? So going back to my template that we have over there, that's the the blue distance, which is the 1/3, right? The blue distance is the 1/3 ratio. So I know I have to use that 1/3 ratio. In the event that the other segment they give me is the median, is MF the entire median? Yeah, okay. So we know we want to relate UF and MF. We want to somehow make these two things equal. Well, UF is the smaller portion. We know it's the portion that relates over here from the centroid to the midpoint. So we know we're going to use 1/3. So say UF is 1/3 of the entire median being MF. And if I think about that, what that's going to do, it's going to take MF, which is the entire median, and it's going to shrink it by a factor of 3. It's going to reduce it so that it becomes a smaller distance UF, right? So that tells me that I've got the 1/3 on the right side of the equation, okay? If I put the 1/3 on the UF side, it would mean that we're taking UF and making it smaller. Well, you can't take UF and make it smaller and say even a smaller distance than UF is equal to MF, which is larger than UF to begin with. Does that make sense? Okay? So always, once you write that generic equation, think back, what is the understanding or the concept of the algebra doing for me? Am I stretching a value or am I shrinking a value? And then think about, okay, did it stretch the right one? Okay? So here we wanted to shrink MF, we want to shrink the larger one, and that is happening with that equation. Okay? I would say that probably most of you maybe did this. 3 UFs equals 1 MF. Anybody do that? Okay, that's perfectly fine. There's nothing wrong with doing that. And you would actually maybe have to do that, and if you left it as this, you would come up with that in your algebra at some point. Okay? I'm going to use the UF equals 1/3 MF. So I'm going to say x minus 10 is equal to 1/3 of 2x minus 16. Okay, now the reason I'm going to do it this way is to show you that if I'm a person that says I'm only going to distribute things, I'm only going to take the 1/3 and multiply it through 2x minus 16, that's perfectly fine. You can do that, but you're going to get 2/3 x minus 16/3. It doesn't reduce real nice. Okay? So maybe that approach, that algebra, isn't really nice. So what you do then is, can I multiply both sides by 3? And then when I pair up these two with the associative property, what's 3 times 1/3? Just 1, right? So then I got 1 times 2x minus 16. So I get this. Come over here, multiply this side by the same 3. So I get 3x minus 30. Okay? That multiplication of that 3 right there is the exact same step that would have been conducted right there. If I go 3 UFs, does that give me 3x minus 30? Equals 1 MF. Is that 1 MF over here? Okay. So whether you do it here or you rewrite it with the 1/3 and the expressions in it like I did, you are still doing the exact same algebra. It's just that your steps are kind of reordered. Okay. But going through here and solving this, you get x to be, what, 14? Okay. Now, all they want to know is what m to f is. So if I plug in 14, I get 28 minus 16 here is equal to 12, right? But I'm maybe not confident in that answer. Okay, so I'm going to see if there are things here that can convince me that I am right. M to f is 12. What would u to f be? Be 4, right? Okay, u to f is 4. What's 4 compared to 12? It's the 1/3 that we knew we should have, right? Okay. What would um be in this case? It'd be 8, right? What's 8 compared to 12?
2/3.
2/3. Another ratio that we know should exist because that's centroid, right? What's 4 compared to 8?
1/2.
1/2. The third ratio that should exist. You should, when you get your concrete values for your solutions, for your distances, you should always be able to plug back in and always get those ratios when you compare. Okay? Now, depending on the order that you compare, I always went with the denominator being a bigger value. If I take 12 and compare it to 4, that gives me 3, right? Well, 3 over 1 is the reciprocal of 1/3. So you can either get 1/3, 2/3, or 1/2, or they're reciprocal. So you might show up with 3 over 1, 3 over 2, or 2 over 1 as well. Okay? If you can get one of those 6 reciprocals to show up, I think that's good enough verification that you've done things correct. Okay?
I want you guys for